Alright, we're on the air. Okay, good night actually, or whatever time it is in your place. My name is Bernardus, and today we will be talking about server and socket programming again. So, the video I recorded yesterday turned out when I audited it today, it contained a lot of mistake. So, here I am after exercise using my school uniforms because I don't want to wear anything else, so like the washing pile wouldn't pile up. And yeah, I fixed it during school. Mind you, during school I typed all of this because yeah, free time, why not use it to learn about network IO? I'm TKJ after all. TKJ. Okay, so without further ado, let's get started. Okay, so socket basic. We'll talk about everything again, alright? While we go, what did I change, what I fixed, and what I learned, and the post-mortem at the end. So throwback to system calls, you should already understand whether you're talking to a disk, a file, or even your GPU, you use the same lingua franca of system calls. Open, read, write, and close. And maybe memory map, but that's besides the point. Unix did this, so the way programmers talk to many things remain the same. Whether it is a file, driver, or even a socket. A socket. Okay, socket. So the next section is about server. So we know that backend lives in a computer server. Let's debunk this madness. Server and computer server. These are two distinct things. The computer server is a computer that hosts your backend or server. It is the hardware, while server is a program that serves other programs. It is the software that is bound to a certain port ready to accept requests. The term server is used interchangeably for computer server and the server software. So it's not like a hardbound rule to say computer server and server, just you should know the difference between the two. The next topic is socket and file descriptor. In Unix, everything is a file. You write to a buffer and the OS will handle the TCP IP processing, breaking down what is in the buffer to send the segments, adding addressing information through the network depending on the destination. Socket is the one file descriptor pointed to. Think of it like a bi-directional highway specialized for communication between the client and the server. It manages communication between the client and the server, so when you write to socket FD, it means you're dumping the data to the socket buffer. Then the OS will take the data, breaks it down following the TCP IP protocol, and sends it down the next layer, which is located in the OS, and will tape the IP and MAC address, travel down the switch to the router, to the modem, and travels to the rest of the world. So, okay, usually when we write to a socket, we use the system call write, right? System call write takes a argument file descriptor. It is a non-negative integer. So there is an internal table called file descriptor table. So on the left side, left row, if I'm not mistaken, on the left row, it is the file descriptor. Meanwhile, on the right, it contains a lot of information. I forget about all of them, but it contains where the buffer is. So when you write to a file descriptor, the operating system will dump it to the buffer. And once the socket sees that okay. So get this. Write takes file descriptor as an argument. When you write to a file descriptor, it means that the OS will dump the data into a buffer. And in this buffer, then the OS will take the data, breaks it down following the TCP/IP protocol, and sends it down the next layer, which is located in the OS, will tape the IP and MAC address. So basically, it will be broken down following the TCP/IP protocol and sent down using the socket connection. Yes, suddenly OSI layers make sense to me because of this. It does not. It just confuses me even more. Okay, the OS will handle. So basically, you should know that socket is a bidirectional pipe, and the one who breaks down the data is TCP/IP. The one who breaks down the data is the operating system following the TCP/IP protocol. Okay, so that's it. This section is incredibly confusing, but to summarize everything, in Unix and Linux, everything is a file. When you write to a file descriptor, it means you're dumping the data to the buffer, and the OS will handle the TCP/IP processing if it is a socket, breaking down what is in the buffer to send the segment addressing the information through the network depending on the destination. It can be a loopback, meaning go back to the own host, or travels down the network. So how many people can I talk to? This section will address how many people can we talk to. Close this one. Okay. So in IP address, which I learned, 127.0.0.1 is reserved for loopback IP. When you bind your program to this IP, it means it's bind to localhost and limited to all the programs inside your host/PC, while 0.0.0.0 means bind to all available network interfaces. It can also mean this host on the network, which will make your server accessible for anyone in the network if they access your IP address on the network and the port. In other terms, for the loopback IP, it means, let's say it's a house, and we bind our server to room 8080. Binding it to 127.0.0.1 means I don't care whether they come from the front door, back door, or even the window. They are not allowed to talk to me except if they are on the same house. They came from the same house. Yes. Meanwhile, binding to 0.0.0.0 means I don't care whether they come from the front door, back door, or even the window. As long as they want to see me, let them in and take them to my room. That's basically it. As long as it's my room, let them in. The next one is ServerSocket and socket. So in C, we need to bind our process to a port and starts listening, but Java already handles that with ServerSocket. It automatically binds your program to a port and listen. Though to accept connection, you need to do socket.accept. You must know that accept is a blocking call. Your program will halt until a client connects. And once a client connects, you will get a socket object, resembling the file descriptor for each connection to the socket. Its connection the socket maintains. It writes to the FD. So let me explain it even further, alright? So as we learned earlier, that socket is a highway of bidirectional communication pipe. So your server is just a normal process that is bound to a certain port. Let's say I have a Java server that is bound to the port 8080. It is only a normal process that is bound to that port. Socket, on the other hand, is a bidirectional communication pipe, as I said. So if a client wants to connect to our server, I should have said, let me wait, okay. So let me explain in the cloud. So the socket means bind our process to the port 8080, and then we wait for a client who wants to connect to our process, to our port, And once a client is connected, we get a file descriptor to talk to that client. Remember, socket is just a pipe between client and the server. So when your computer server wants to send data down to the client, we write using the file descriptor to this pipe communication. That's basically it. Okay, I don't know if that is clear enough, but let me explain it once again, alright? Because I'm also trying to learn it, right? So this is our process. A server is just a process that serves other program and is bind to a certain port. Let's say port 8080. When a client wants to connect to our server, the operating system will handle it. So I want to connect to this server right here, and then it establishes the communication. The pipe communication between the client and the server is called a socket. So when you want to write to the client, the server has a file descriptor to transfer data down this bidirectional communication. That is my mental model. Again, correct me if I'm wrong, but that is my mental model. So I'm not gonna recompile this, I'm not gonna run it because I've seen this one enough. It is only a simple echo, if I'm not mistaken. Might not hurt because I've already started IntelliJ. So yeah. Let's start. You gotta be kidding me. Oh no. Why update now, man? Why update now? No. Okay. Sorry. I'm just gonna MC localhost 8080. I'm gonna say hello, echo hello, hello world. Yes. Okay. So in this code, I will explain my architectural decision. Yes, architectural decision. Okay. I will explain my architectural decision. Okay, so this one right here binds our process to a port 8080. This one waits until a client is connected. Once a client is connected, the file descriptor, we get the file descriptor, and the pipe is active. We use buffer reader to read line by line. We use file writer to write to a file, and we use print writer to write to the socket. Yes. The reason I use this buffer reader is so that we read line by line, not asking the CPU for every byte, nor do we ask the whole chunk, which could take gigabytes and destroy our computer server. File writer and print writer, if I'm not mistaken, they should I don't know about the file writer, but the print writer swallows the error, so it's not good for long-term deployment, but during prototyping I'm gonna use it. We use print writer so we don't need to flush manually nor forget it, and so the error doesn't break the request, and print error swallows the error and suddenly fail. Though this is actually bad, because in a server you want to catch exception and severs the bad request immediately. So okay, you remember that accept is blocking, and after client is connected, we immediately serve the first client. So if another client connect, they will be put in a waiting list or be ignored. So I skipped a bit of things right here. So every socket connection means a file descriptor. But how do we not run out of file descriptor? Modern VPS can change their limit of file descriptor to 1024 or 65,535 or even 1,048,576. And the size of each socket is so small, you don't even need to worry. But you still need to close its connection once they're finished, because file descriptor leak is a problem, and "I'll close it later" might be the last words your server will ever hear. So that's why I use try with resources, so I don't forget to close things, and try automatically closes things. Pretty nice. So now we entered the realm of HTTP request. Day 2. As usual, I am TSL. Until now, I'm still tired. So today, and I woke up at 3 a.m. writing day 2 and day 3, and they turned out to be wrong. So in the end I spent for 3 days as usual. So the first one is TCP and HTTP. It is the request structure. So we've heard about HTTP request and TCP IP, but what are they actually? TCP IP, the handshake protocol. In networking, TCP IP is the protocol in which the HTTP is also a protocol, but they are different. TCP IP is the protocol in which handles how data is sent. It is usually OSI layer 4. It primarily is the protocol for breaking and sending/reading data safely. This is also the reason why you don't see a hole in your website. It manages the corrupt data, asks for more if I'm not mistaken, and yeah. Now HTTP is also a protocol, but primarily lives on the 7th layer of OSI layer, application layer. It is the protocol in which the data will be structured so the browser could understand. So HTTP requests, can I order an index.html? Okay, so RESTful API was intended to follow HTTP protocol as much as possible, not the other way around. So GET, POST statuses came from HTTP. HTTP request usually comes only in 3 to 4 sections. The first one is the request line. Okay, I forgot to say this, but server is actually passive. It serves other program, not tell other program what to do. So this line tells your server what to do. You need to parse this line. It includes a verb, get, post, put, or delete, the thing you want to get, and the HTTP version. Something like this. It is the first verb. It means get me the index.html with the HTTP version of 1.1. The next section is the headers. These are like extra information for someone. My house has a blank color fence, or I'm verified, let me in. Usually authorization is put right here. The next one is the empty line. HTTP protocol dictates that the headers must end with a double new line. Basically a blank line right here before optional body for post, put, and get response. This is only for get and delete. For post and put will be discussed later because we need content length and content type. This is actually an example of this, and this is a simple get server in Java. I'll paste this one. Stop and rerun. Okay. Okay. Now you see, I get the HTML, but because I haven't written the rest of the request, especially the double line, the request is still going. But once I wrote the double line, it immediately ends because double line for get means the last line before body, but because it is get, we don't need the body. So yeah. So okay, status code mean is basically a way of the server saying, is everything okay down there? There is the 200 family, means everything is good, nothing is bad. It means just your request was completed successfully. 204 okay, 201 and 4 created, 204 and no content. Bad request, the 400 family means your request is not executed, because you are at fault. The first one is bad request, 400. It means your HTTP request doesn't make any sense and you're speaking a gibberish. 401 unauthorized means you're an intruder, you're accessing something you shouldn't do. 403 means forbidden, you don't have access to access this data. 404 not found, and 405 method not allowed. Basically, your server only handles specific verbs like get, but you ask for delete. 500 internal server means we're on fire. The server is on fire. It is generic crash code. Doesn't mean your server is shutting down, but most of the time it is. The next one is 501 not implemented. Means, yeah, it is not implemented yet. What you ask haven't been implemented yet. The next one is 503 service unavailable. We are down for renovation or we are busy. Yeah, either the two. The next one is content length and content type. At this or fire. Not fire exactly, but for post put and response in get, you need these two. So browser can render things correctly. Content type is so that the browser can understand, okay, this is HTML, so I will render it as a website, not let the client download the HTML. As for content length, remember earlier that the body is optional. We need to parse exactly how many bytes the body is, how big is the body. So that's why content length is necessary. So you can parse exactly what you need and doesn't waste memory in buffer nor corrupt your data. This is an example. This is all most used content type in HTTP requests. This is a single threaded server. Let's paste this one. So let me read the code first. Okay, so we bind our process to the port 8080, and then while true, we ask for input. While true, we ask for input right here. We are ready to accept client, and once a client is connected, we'll immediately start reading from the client. Once the client is connected, we immediately connect the print writer to the output to the socket, yes, and then we read the first line. If the first line is null, then it is already an invalid request. We continue, but if it is not empty, we split the string of the first line. Is it the first one we parsed is the verb. Is it get, post, put, or delete? The next one is what the user wanted. Is it index.html or another file called .html? And then we get the path. We create a path to the static, since most of my files are located in the static. And then we have content length, and then we create a placeholder for header. So we start reading line by line what's in the HTTP request, but we only check what we need. That is the content length. How big is the content we are dealing with? And then we get to that part whether we are handling get, post, put, or delete. And if it is bad request, immediately we send it a bad request. So let's see the handle get first. Handle get means getting things, right? So if files exists and it is not a directory, we get the file size, and then we get the file type, and then if everything goes smoothly until this point, we send that everything is okay. This is the type, this is the size, this is the we create an empty line. We immediately print everything and start streaming down the file to the HTTP to the socket. If we don't find anything, it is for not bound. And then post means creating new things, right? So we create a new char array with the length of the body, and then we read from the input. We read, and then yes, we create a new string to the path. The path, yes. If I'm not mistaken, this write string creates no. This means write the string to the file target, but this automatically creates the file, and then we start. This should be 201 created. This is my old code, so it's a bit messy. The only difference between handle put and handle post is that has the file existed or not. If it has existed, okay. If it is new, then 201 created, and then we have handle delete. Delete if exists, no content. If not, not found. Send status means just sending the status. Yes. Exception: if the print router is not null, we say that the server has an error and send it. And after everything is done, we close the connection. So that's basically what's in it for this code. My code has been running, so if I'm not mistaken, I'm gonna use curl. This is HTTP, right? Not HTTP. Oh, okay, sorry. Yes, because I didn't specify what I wanted, so it goes to the slash only, and if it is slash only, we get index.html. But then I want to do post. Oh shit! Oh no, I cursed. Okay, sorry. How do people do it when fail to open? Okay. This is okay. As you can see, it's created right here. We basically asked to create it is put, not post. So post right here. So it means that the put actually works because it's created immediately. Okay. Look. What? Okay, but this means it works, so I now need just to delete things. Yes, delete. it's not HTTPS. That's why it's no content. Okay, so this server is functional. Okay, I didn't know why it was erroring. So now we're entering security and concurrency. This is where I did most of my mistake. So yeah. Okay, so the first one is SSL and TLS. No sniffing around. We know that data travels in byte through the network. Anyone can take it, anyone can reshape it, and anyone can read our password over the internet. So that's why SSL, Secure Sockets Layer, is annulled and technically deprecated. And the new one, its successor, Transport Layer Security. Even though it's called SSL certificate, it actually means TLS. So think of TLS like a lock. Everyone know the key and password to it, but there is no key or password to unlock it. So that hacker can take the bytes. But it's used once, so reply attacks won't happen. First time you visit a website, the browser sends a list of supported encryption algorithms and a random number to the server, like salting, called nonce, number used once, so reply attacks won't happen. Your server picks the strongest algorithm and sends back its public certificate. The public logs that follows the X.509 standard everyone have, alongside the public key, the domain, who issued the certificate, the validity period, the serial number, and the digital signature. The browser checks the certificate, and as a note, localhost isn't owned by anyone, and you can't have a certificate agency certificate that localhost is yours, because every PC has localhost. So CA can really know it's you. The browser creates a pre-master secret and encrypts it with your public key. Only your private key stored in your .p12 file in the server can unlock it. Your server unlocks the locked pre-master secret. Both sides now have shared session key. Now all your HTTP requests is locked behind a TLS tunnel, making it an HTTP secure. And as a note, to prevent replay attacks, this process is repeated many times. A new tab, refresh, start, you name it. That's TLS. But psych, I just realized that I explained the outdated RSA. In modern TLS, we use DV-Hellman. Let me try to explain it. Right? We have 6 variables, 2 private and 4 public. We start with 2 numbers everyone can see and agree upon, the server and the client. P, a very large prime number, modulus, and G, a base number. Then the client picks a secret number A, but we'll call them the same for server with B. So now everyone, both client and the server has P and G, but client has A, server has B. This number never leave the machine, nor they need to, due to the magic called mathematics. So these 2 are the private variables. Both server and client send each other capital A, which is the result of G, base number, to the power of A, with the modulus P, meaning the modulus of P to the base number to the power of A. The same with server, just with B. So the client sends capital A, which is G to the power of A, modulus P. Meanwhile, the server sends B capital G to the power of B modulus P. Now here is the magic. Both performed one last formula. S equals B to the power of A and A to the power of B. Now they end with the same number, that is the password of each HTTP request. Do I understand? No, but at least I get the hang of it. The reason that this is more secure is that if your server is hacked or someone compromise your .p12 file, or even worse, push your .p12 file to GitHub, you won't suffer as much. But everything in DV-Hellman is temporary during a handshake, so it's safer. The last one is a really exception. We have covered everything in threads and virtual threads, so we'll implement a secure and mini concurrent server. And as a note, this uses the old and outdated RSA handshake. So I won't be really diving deep into it, even though in the last video I say I would like learn about this SSL context, but I won't dive too deep into this, nor I would dive deep at all, because I will be learning about the real secure way of doing it with the latest TLS version. Where is read? Where is read? Okay, to get the HTML, as you can see, this is post request. It's working. We put hello world to it. Okay, it works. And the last one we delete. Alright, so that's everything. So now the postmortem. I messed up in the last recorded video. I stuttered a lot, didn't fully understand the TLS implementation, and also messed up a bit in the notes. This is everything that I fixed tonight. It's TLS, not TSL. I did a typo. I typoed a lot. It's loopback IP, not callback. The reason it's called loopback because it never leaves the device via network interface card. Rather, it goes back to the machine. The TLS handshake is outdated. This is what I talk about. What I explained was RSA key exchange. While not necessarily wrong, it is outdated. I added explanation for DV-Hellman key exchange that uses math as a way to securely send messages. Minor typo, it is application octet stream, not strat. So my note about swallowing errors in print parenthesis path, we need to know what's wrong. JavaScript is an application data in meme type, not text. And the reason this is confusing is I took OC layer literally, like word to word, instead of using it like a map. That's why I'm confused. Why is switch lower than the why is switch low down the layer on layer 2 compared to router in layer 3? When we hit switch first before the router or pro to connect the PC to the switch, it travels through cables. It's layer 1, right? So I took OC layer literally, and it made me even more confused than it helped me. So I haven't understood my implementation in the last code, but I'm gonna change it in my mini Tomcat implementation with the latest TLS and more robust. So that's for today. It's already late. I am gonna sleep after this. So yeah, without further ado, let's end it. So yeah, Bernardus, signing off. Thank you for watching, I guess.